Today topic is Combinatorics and mathematical induction. Combinatorics is the branch of the mathematics which is related to counting. It deals with arrangements of objects as well as the enumeration tips, that is counting of objects with specific properties. The roots of the subject can be traced as far back as 2800 BC or BCE, when it was used to study the magic square and pattern within them. Fundamental principles of counting. There are two countings. One is the sum rule. If the first task can be completed in m different ways, first task is completed in m different ways, and the second in n different ways, and if these cannot be performed simultaneously, then there are m plus n ways of doing either task. This is sum rule of counting. Sum rule of counting is one is m different ways, another one is n different ways. Sum of the two different ways is m plus n ways. Okay. Next, product. Let us suppose that a task of the producers, if the first task can be completed in m different ways and the second in n different ways after the first procedure is done, then the total number of ways of completing the task is m cross n. Here one different ways is m, another different ways is n. Product rule is m cross n. Okay. A person went to restaurant for dinner. In the menu card, the pattern saw 10 Indian items and 7 Chinese food items. In how many ways the person can select either an Indian or a Chinese food? Selection procedure. They are using addition procedure. Sum rule. Number of selection of Indian food is equal to 10 ways. It is given. Number of selection of Chinese food is equal to 7 ways. By the fundamental principle of addition, m is 10 and n is 7. M plus n ways is addition of the procedure. So, Chinese food or Indian food is the number of selection of Indian food or Chinese food is m plus n ways. M is 10 plus 7, so 17 ways. Is equal to 17 ways. Subdivision number 2. There are 3 types of toy car and 2 types of toy train are available in a shop. Find the number of ways the baby can buy a toy car and toy train. Type of toy car is equal to 3. Type of toy train is equal to 2. By the fundamental principle of multiplication, this is m ways, this is n ways, m cross n ways is answer. Okay. So the number of buying a toy car and a toy train is equal to 3 cross 2 is equal to 6. 3. How many 2-digit numbers can be found by using 1, 2, 3 and so on? 1, 2, 3, 4, 5 without repetition of digits. Without repetition of digits is important. Suppose the question is how many 2-digit numbers are there? Then answer is 90. But in this case, using 1, 2, 3, 4, 5 without repetition, the number of 2-digit numbers is, first time we have to take 5 numbers. So one digit is 5C1. 5C1. 5C1 is 5. Next, the repetition is without repetition. So, repetition is not allowed. Therefore, 10 digit subtract 1 from 5. So, 4C1. 4C1 is 4. So, 4 into 5 is 20 ways. Okay. Next, question number 4. 3 persons enter into a conference hall in which there are 10 seats. How many seats? 10 seats. In how many ways they can have or they can take their seats? The total number of persons equal to 3. Number of ways getting a seat for first person is 10. The number of ways of second seat for second person is 10 minus 1, 9. The number of ways of getting a seat for third person is 9 minus 1 is 8. So, the answer is 10 into 9 into 8 is using the product rule is answer. So, the number of ways getting seats for 3 persons in conference call is equal to first is 10, second is 9, third is 8. Product of these 3 terms is 720. How many ways 5 persons can be seated in a row? A single row, 5 persons can be arranged in how many ways? First, 5C1. 5C1 is 5. Second, 4C1. 4C1 is 4. Third, 3C1. 3C1 is 3. 2C1. 2C1 is 2. And 1C1 is 1. So, product gives answer 5 into 4 into 3 into 2 into 1 is 120. Next, question number 2. A mobile phone has a passcode of 6 distinct digits. What is the maximum number of attempts one makes to restrict to the passcode? Let one digit number be. Let the one digit number be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The maximum number of attempts made to restrict to the passcode is equal to 10 into 1, 0, 10 into 9 into 8 into 7 into 6 into 5. So, answer is 1,51,200. Sum number 3. 4 children are running in a race. Number 1. How many ways can the place be filled? First 2 places can be filled in ways. First is 4, second is 4 minus 1 is 3. So, totally 12 different ways would they finish the race. The race finished in a ways is equal to 4 into 4 minus 1 is 3 into 3 minus 1 is 2 into 1. 4C1 is 4, 3C1 is 3, 2C1 is 2, 1C1 is, so totally 24 ways. Question number 4. Count the number of 3-digit numbers which can be formed from the digits 2, 4, 6 and 8. If number 1, repetition of digits is allowed. Number 2, repetition of digits is not allowed. Number 1, total number of 3-digit numbers, repetition is allowed. 4 into 4 into 4. Allowed means the taking the digit including the digit. So 4, again 4, again 4. 4 4s are 64s are 64. Number 2, total number of 3-digit numbers. 3-digit numbers means first 4, next 4 minus 1 and 3, next 3 minus 1 is 2. So 4 into 3 into 2 is 24. How many? Sum number 5. How many 3-digit numbers are there with 3 in the unit place? So total number of 3-digit numbers is equal to 90. In using the digit 3 in the unit place. Okay. Without repetition using, we get total number of 3-digit numbers equal to 64. Why? The reason is 9 minus 1 is 8. 8 into 8 into first digit is 1. How many 3-digit numbers? 3-digit odd numbers. 3 digit odd numbers can be formed by using the digits 0, 1, 2, 3, 4, 5. Number 1. The repetition of digits is not allowed. Number of 3 digit odd numbers is equal to 4 into 4 into 3. Repetition is not allowed. 48. A repetition of digits is allowed. Number of 3 digit odd numbers equal to 5, 6 and 3. Multiplying we get 90. Sum number 9. How many 3 digit numbers which are divisible by 5 can be formed by using the digits 0, 1, 2, 3, 4, 5. Number 1. The repetition of digits are not allowed. Number 2. Repetition of digits are allowed. First question number 1. Repetition of digits are not allowed. So, number of 3 digit numbers, repetition of numbers not allowed is 4 into 4 into 2, 32. Number of 3 digit numbers, repetition is allowed. Repetition is allowed means 6 minus 1 is 5 into first is 3. So 2. Therefore 6 into 5 is 30. 32s are 60 is answer. Sum number 10. To travel from a place capital A to place B, there are two different bus routes B1 and B2. Two train routes T1 and T2 and one air route A1 from the place B to place C. There is one bus route B1, two different train routes say as is to T2 dash and one air route A1 dash. Find the number of routes of the commuting from place capital A to place C via place B without using similar mode of transportations. By the given instruction, the route map of the diagram is as follows. A, B, C are the routes. The similar mode transportations are as follows. From A to B, B1 T1 dash, B1 T2 dash, B1 A1, B2 T1 dash, B2 T2 dash, B2 T2 dash, B2 A1 dash. From B to C is T1 B1 dash, T1 A1 dash, T2 A1 dash, T2 B1 dash, T2 A1 dash, A1 B1 dash, A1 T1 dash and A2 T2 dash. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total number of routes are 13. Next, find the value of 6 factorial. We know that n factorial is equal to n into n minus 1 into n into n minus 1 factorial. This can be written as n into n minus 1 into n minus 2 and so on to 1. n factorial means n into n minus 1 into n minus 2 into and so on to 1. This can be written as n into next n minus 1 factorial. Using the factorial formula, 6 factorial is equal to 6 into 6 minus 1 5 is into 5 minus 1 4 into 4 minus 1 3 into 3 minus 1 2 into 1 is 720 is answer. Factorial plus 5 factorial. 4 factorial is 4 into 4 minus 1 3 into 3 minus 1 2 into 2 minus 1 1. 5 factorial is 5 into 5 minus 1 4 into 4 minus 1 3 into 3 minus 1 2 into 1 factorial. So adding first is 24, second is 120. Adding these two we get 144. Next, solution number 3. 3 factorial minus 2 factorial. 3 factorial is 3 into 2 into 1 minus 2 factorial is 2 into 1. So 3 2s are 6, 6 minus 2 is 4. Next, solution number 4. 3 factorial into 4 factorial. 3 factorial is 3 into 3 minus 1 2 into 2 minus 1 1 into 4 factorial is 4 into 3 into 2 into 1. Multiplying we get 144. Next, solution number 5. 12 factorial divided by 9 factorial into 3 factorial. 12 factorial can be written in the form of 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Denominator 9 factorial is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 3 factorial is 3 into 2 into 1. Cancelling all these things, we get 2 into 11 into 10 is 220 is n plus 3 factorial divided by n plus 1 factorial. N plus 3 factorial is n plus 3 into n plus 3 minus 1 is n plus 2. N plus 2 minus 1 is n plus 1 factorial divided by denominator n plus 1 factorial. Cancelling these two, we get n plus 3 into n plus 2. Multiply these two factors, we get n square plus 5n plus 6. Sum number 15. Evaluate n factorial divided by r factorial into n minus r factorial when case number 1 n is equal to 6 and r is equal to 2. Substitute n is equal to 6 and r is equal to 2. Then n factorial divided by r factorial into n minus r factorial, we get 6 factorial divided by 2 factorial into 4 factorial is 6 factorial can be written in the form of 6 into 5 into 4 factorial whole divided by 2 into 1 4 factorial. 4 factorial 4 factorial cancelled, we get then 1 2 is 2, 3 2s are 6, so 3 into 5 is 15. Next substitution number 2, n is equal to 10, r is equal to 3. Substitute n is equal to 10 and r is equal to 3 in the given form. n factorial divided by r factorial into n minus r factorial, we get 10 factorial divided by 3 factorial into 7 factorial. 10 factorial can be written in the form of 10 factorial 10 into 9 into 8 into 7 factorial whole divided by using the formula n factorial is equal to n into n minus 1 factorial. N factorial is equal to n into n minus 1 factorial. Okay, now denominator 3 factorial into 7 factorial. 7 factorial cancel 2 into 1. Cancelling these two, 1 2 is 2, 4 2s are 8, 3 1 3 is 3, 3 3s are 9, therefore 120. Substitution number 3, for any n with r is equal to 2 using n is equal to n and r is equal to 2 in the given n factorial divided by n factorial minus n minus 2 factorial is n factorial into n minus 1 into n minus 2 factorial whole divided by 2 factorial into n minus 2, 2 n minus 2 factorial, n minus 2 factorial cancelled. The numerator is n into n minus 1, denominator is 2, factorial is 2 into 1, so 2. So n into n minus 1 divided by 2, multiply n into n minus 1, we get n square minus n divided by 2. Sum number 16, find the value of n if number 1 n plus 1 factorial is equal to 20 into n minus 1 factorial. N plus 1 factorial is n plus 1 into n into n minus 1 factorial is equal to right hand side 20 into n minus 1 factorial, left hand side n minus 1 factorial and right hand side n minus 1 factorial cancel. We get n into n plus 1 is equal to 20. This can be written as n square plus n minus 20 is equal to 0. This means n square plus this n can be written in the form of n square plus 5n minus 4n minus 20. Take first two terms n into n plus 5 minus take last two terms minus 4 into n plus 5 is equal to 0. n plus 5 is common into n minus 4 is equal to 0. So n plus 5 is equal to 0 means n is equal to minus 5. N minus 4 is equal to 0 means n is equal to 4. We have to take positive value only. Therefore n is equal to 4 is answer. Okay. Next substitution number 2. 1 divided by 8 factorial plus 1 divided by 9 factorial is equal to n factorial divided by 10 factorial. First 1 by 8 factorial plus 1 by 9 factorial can be written in the form of 9 into 8 factorial is equal to n divided by 10 factorial means 10 into 9 into 8 factorial. So left and right common 1 by 8 factorial. So left hand side 1 by 8 factorial into 1 plus 1 by 9 is equal to right hand side n divided by common 1 by 8 factorial into 10 into denominator 10 into 9 is remaining part. So cancelling left and right 1 divided by 8 factorial is cancelled. 1 by 8 factorial is cancelled. Next remaining part 1 plus 1 by 9 is equal to n divided by 90. 9 into 10. Now left hand side taking LCM, we have 9 plus 1 divided by 9 is equal to n divided by 9 into 10. Left and right denominator 9 will be cancelled. Next 10 cross multiplying, we have 10 divided by 1 is equal to n divided by 10. Cross multiplying, we get 10 times of 100. 100 is equal to n. So 100. Today homework EX number 4.1, sum number 2, subdivision number 2, sum number 6, subdivision number 1 and 2, sum number 8, subdivision number 1, 2 and 3, 11th sum, 12th sum and 13th sum. These are the homework problems. Any doubt, reply the message. Thank you.